Welcome to this session on Solid Edge modular plant design, library part and pipe specification management. Here is today's agenda. We will go through the detailed workflow process of creating and managing library parts, creating and managing pipe specifications, as these are two key areas which later will help in building pipe assemblies and generating isometric drawings in Solid Edge modular plant design. Then we will see how we can make use of library parts and pipe specifications for designing piping assemblies, followed by isometric drawing creation. We will show what information has to be defined on the standard parts, and then how the solution makes reuse of the knowledge we placed on the library parts and pipe specifications in building pipe assemblies and isometric drawings. Let's see the process. First is downloading and creating parts. Here we can download the parts from a supplier portal or third-party tools like 3D Find It, or we can refer to the product specification and design the parts. Second is defining connection points by placing coordinate system and S-key parameters in Solid Edge. Third is to register the standard parts to the library database with respective categories and defining characteristic property values. Fourth is to create the pipe specification by adding key names and assigning the right part against it, also specifying the settings which basically control how the piping assembly has to be built. We can assign a part either from the standard part library or through File, the System folder. The above steps are necessary to build a piping assembly and isometric drawing. The next step is designing piping assemblies, and finally the automated generation of isometric drawings from piping assemblies used in fabrication or manufacturing process. Both the 3D piping assembly or digital twin and the isometric drawings are generated from the data previously inputted. It is therefore both fast to generate and consistent as it is based on the original data. We will use tri-clamp unions, fittings and valve examples for this session. As mentioned earlier, we can find these parts on 3D Find It, or we can browse on supplier websites and download the parts of a specified site. In this video, we will see how to download and create new standard parts in Solid Edge. This is the first step as we need 3D geometry for the new standard part. Most of the parts are available on supplier websites or third-party providers like Trace Parts or 3D Find It. You can download the parts using the option Components by 3D Find It. It is the interface which connects to 3D Find It database, which has information on thousands of parts from many suppliers and 3D CAD data. Here you can search the database based on multiple parameters like supplier name and component type, or only component type, and then again we have the option to filter based on supplier. You can search based on classification and catalogue, geometry-based search, sketch search, text-based search, and so on. You can also search based on supplier, for example, the manufacturing part number. Once it shows the resultant part, we can either download and later open the part in Solid Edge, or you can use the option Send to Solid Edge to open in Solid Edge. Here is a valve assembly. However, accessories like the valve handle are missing. These can be downloaded separately and assembled onto the valve. You also have the option to search in the supplier portal, and many suppliers do provide the 3D CAD parts with product specifications which can be downloaded. You can pick the right part family member based on the requirement to download, view the properties associated to it, and later open in Solid Edge for adding the coordinate system information. In this video, we will see how to define the coordinate system and S-key parameters for the standard parts like pipes, components and fittings. Let's start with pipe. We can create the pipe part with basic sketch profile, which is a cross section of the pipe, and extrude with some default length value. Here we can define the circle outside diameter, wall thickness and length as variable, which can be referenced to sketch and extrude dimensions. The length expression should be a variable, as this is the value which will be read by the system and replaces the pipe length in the actual 3D piping assembly. The coordinate system and S-key parameters can be defined either with the coordinate system wizard or component wizard options. Both options are used for the same purpose. Later, this coordinate system information will be used while the piping assembly is generated, and S-key and component type information is used whilst piping isometric drawings are created. In this case, select the component type as pipe and click on Add to define the first connection point. You can enter values against the size field. Use the option Define CS by Geometry and select the circular edge, and it automatically creates the coordinate system, and x-axis will be pointing perpendicular to the selected edge. Similarly, define another connection point at the other end of the pipe. Click Next to continue. In the Property dialog, enter a value against the properties as required and fill in mandatory properties, for example the pipe OD and wall thickness. You can define pipe as component type and specify size value. Click Next to continue. Define the S-key parameter for the pipe. You can select one from the drop-down list as per your pipe type. This value and component type values are used while creating the isometric drawings of the piping assemblies. You can also refer to the symbol keys attachment to get definitions and standards. Click Next to continue. You can save this file with a new name under the standard part folder structure, maybe by creating a new folder. A new part gets saved at the specified location with all of the coordinate system information. Later, the part can be registered to the standard part administrator. Close the part to continue. Let's define the connection points for the flange in a similar way. Select flange as component type in the component wizard and click Next to continue. Here, define the connection points at the pipe end. Select the end treatment as welded neck and select the circular edge. Similarly, define another coordinate system at the mating end. and select the end treatment as flanged and click Next to continue. Specify the component type as flange and size value as DN50 and click Next to continue. Specify the right S key parameter as per the flange definition and click continue. Define the component name and folder location where the part should be saved and click Finish to create the same. The next component is the counter flange. Select the options as counter flange from the list in the component wizard. Set all definitions needed to be defined like the flange. Define the coordinate system and S key parameters accordingly. Open the clamp gasket part. Now we will define the coordinate system using Component Wizard, where you can define two coordinate systems for the gasket component type. But this clamp gasket has a flange on both sides, and then a tri-clamp will get placed around the outside of the gasket and flanges. So if you go through the help, the clamp gasket needs three coordinate systems. So we will use CS Wizard to define the same, i.e. on both ends with end treatment as ET10 and at the centre as ET18, i.e. tri-clamp coupling, for which you can select existing coordinate and reorientate as required. For all the three, x-axis should be perpendicular to the selected circular edge. Open the clamp part or assembly using CS Wizard, select the component type as clamp and click Next to continue. Here you can select the end treatment as end treatment 18 and end condition as LC or linear clamp. Specify a coordinate system and pick the CS on the display and reorientate that x-axis will be perpendicular to the clamp face. Add two new properties using File, Properties dialog. Set component type as clamp and S-key property to CLMP. Save the file. Copy the whole assembly from the saved older to standard part folder. Open the butterfly valve assembly. Click on Component Wizard. Select Valve and Butterfly Valve from drop-down list. Here we need to define two connection points, one at each end of the pipe, and one connection point for the spindle direction. This is optional. Define the end treatment as flanged and select the circular edge. You can also define the connection point if it is an input or output. Set the component type as valve and S-key value as VYFL and save it to the standard part folder. Open the elbow part using Component Wizard, select component type as elbow and define the connection points at both pipe ends. Define the end treatments as flanged and define the size. Then click Next to continue. In the Properties field, define the component type as elbow and size. Click Next to continue. Define S-key parameters as ELCL and click Next to continue. Provide the component name and save the new component to the standard part folder. You can see the same information for the coordinate system, component type and S-key parameters under File Properties. Next, open the T-fitting. Open the component wizard and select the component type as T and select Next to continue. As it will have 3 pipe ends, we need to define 3 connection points. Click on Add, select the end treatment as flanged and select the outer edge to create the first coordinate location. Similarly, define the other connection points at the opposite end and the third connection point at the intersecting pipe end. Click Next to continue and define the size as DN50 under Properties table. Click Next to continue and select the S-key parameter as TECL. These will vary fitting to fitting, so define appropriately as this value will be read whilst the isometric drawings are created. Save the assembly in the standard part folder location. Open the blind flange and initiate the component wizard. For these types of parts, we need to define an output point and a tapping point. Select the edge center for the desired output point and define the end treatment as flanged. Similarly, select an edge at the end to define the connection point, but do not specify any end treatment condition. Click Next and define the S-key parameter as FLBL. Again, click Next and save the file under the Standard Part Library folder. It is good practice to hide all the coordinate system information of the standard parts when we save them. We did not hide the coordinate system features before saving the parts. So let's open all the standard parts one by one, which we saved into the standard part folder, and hide the coordinate system features and save the file again. In this video, we will see how to register the parts to the library database so that these parts can be managed and accessed from the library. First, make sure that the library folder locations are set correctly and all the parts exist within the same folder structure. We will continue from where we left off, i.e., after we created the required standard parts and saved them locally under the Tri-Clamp folder. Let's open the Standard Parts Administrator. Here, we need to register the parts into specified categories. In case a category is not specified, it can be created while registering the parts. You can register the parts using the Add Parts option. Here we have multiple options to add parts to the database. We will select the Single Part File option as we don't have the category defined for the parts which we are adding now. Select the Add from Existing Single Part File option and click on Next. Select Piping Part option and browse the part to be added. In this case, we are selecting a pipe part. Click OK to continue. The registering window will appear. Click Yes. This information window appears as the part is missing the category and characteristic information. Select a right category if it exists, or we need to create a new category. Here we will create a new category under Supplier Parts and name it as Tri-Clamp Standards. Again, we can define a new category under that, and these can represent different types of tri-clamp fittings. Here we will create a new category as pipe. Once we define and select the category, we need to define all the characteristics for that category. All the required characteristics have to be defined correctly for the selected categories. For pipe, we will add outside diameter, which is constant for this pipe, that is 53 millimeters. Then we will add a new characteristic, wall thickness, which is also constant and will specify the value in the field. Next we will add length as a variable characteristic. Enter the part name value. In this case, we will keep it the same as the file name. Click OK to continue.
You can browse to the newly created category which we call Tri-Clamp Standards and Pipe. When you select the pipe, you can see the new part which we just registered to the database by assigning 3 characteristics: length, outside diameter and wall thickness. We will now add a new bend fitting. We will now add a bend fitting under a new category, Bend 90. Also define the new characteristics as normal size with the unit class as text and set the value as 50. Also check the unit value is set to millimeters. After registering, the same can be previewed by selecting the new category as we did before. Using the same method, we can add the rest of the components like blind flange, clamp, counter flange, gasket, T, valve and so on. The procedure to register is going to remain the same. Category and characteristics may vary depending on the fitting or component. Please go through the remaining video portion for the same. Before creating pipe specifications, we need to set up the environment using the Pipe Design Administrator. In the pipe specification settings, set the correct directory where all pipe specifications are saved so that the Solid Edge, P&ID and Piping Design applications will read the pipe specifications from that directory. You can also set the default pipe specification to be used while building piping assemblies. Similarly, set the directory if parts are stored under standard part directory and need to be selected while building pipe specifications. Save the settings to apply. Launch the pipe specification editor, which enables us to create and modify pipe specifications. Let's open a pipe spec and understand the structure before creating a new pipe specification using tri-clamp parts which we previously created. As discussed earlier, you can add parts to the pipe specification either by browsing standard part database, or we can link a part against a key name by browsing and selecting it from the file system. Let's edit and link a part against key name pipe using file system options. As we have already defined the parts with the coordinate system information and S-key parameters, here we can select the option as existing modular plant design component, and from the standard part folder select the pipe part. So when the piping assemblies are created using the pipe specification, this same pipe part will be used. Now let's edit the second row called flange, and this time let's link the flange part using Solid Edge standard parts. Browse and select the custom flange part from the tri-clamp standards category. Click Select to continue. Now the selected flange part is linked to flange key name. When piping assemblies are built, the system is going to add this flange to the assembly. You can define more than one row, i.e. more than one part for the same key name, and favourites can also be predefined. Let's create a new pipe specification and add all the parts which we have previously prepared. Click OK to default selected columns. Diameter columns are automatically populated so that the size can be defined for all the parts. Let's start with pipe key name, define the diameter size as 50 and browse to the corresponding part in the standard part administrator and pick the correct part. You can search or sort on the diameter against the pipe category. We can also search and sort based on multiple properties. Click Select to continue. Add a new row for adding flange. Similarly, browse and select the flange part from the standard part database and define the size as 50. We can continue adding the remaining parts like counter flange, blind flange, bend 90, clamp, gasket, T and so on. The steps for adding these parts to the pipe specification are the same, i.e. add new row, define the key name, define the diameter size, and select the part from the library database. We can define multiple parts with the same key name and size. In this case, you can select one part as a favourite. We can specify a name for the pipe specification with a unique pipe specification ID. Save the pipe specification. We need to make sure a set of fittings which are required for building pipe assemblies are defined with the correct key names and size. As in this case, bend and 90 is defined with size 40. However, there is no pipe defined for the same size. Change the size to 50 as that bend fitting is of size 50 diameter, and save it to the pipe specification folder. We have used the default key names. However, we can define custom key names and, if required, can associate them with a quick place method. As we see here, butterfly valve is added as a key name. So let's add globe valve as a new key name. Now, when we add a new row, in the list you will see globe valve, which we just created. In this example, let's add a butterfly valve and link a 3D part which represents the valve here. Finally, save the pipe specification. Let's make use of the pipe specification to create the piping assemblies. For this, we need an assembly file, a sketch and a pipe spec. We have already created the pipe specification. Let's create an assembly in Solid Edge and save it before continuing. Start the piping application using Run Piping option. Use Create Route feature and select Inactive Assembly option. Now, with Routing Path Line option, create a sketch and also split a line and create a new line from the split point. If needed, we can constrain or provide dimensions to these line segments. After finishing the sketch, come out of the sketch environment. Click OK to the piping information. This information is being shown as we still have not defined the pipe specification, which is to be used to build the piping assembly. Now, both the pipeline segments from the piping window and using the context menu, select Generate Pipelines. From the list of pipe specifications, select the tri-clamp standards and select diameter 50. As we have defined only one size in the pipe specification, the same information is being shown. It also shows the list of fittings which are available for the selected size. If required, you can preview the component. Click OK to continue. Now the system starts creating the piping assembly based on the size and pipe specification you have selected and based on the sketch geometry. It places the fittings at the required places. Now let's zoom in and review the piping assembly which has been created. It has added a clamp between a fitting and flange. If you hide the clamp, you can also see the gasket which is placed at the centre. We can also see the fittings which are placed at the intersection. This is a T-fitting with flanges at the pipe ends and gaskets in between. At the pipe ends, we can see blind flange has been added. Now let's edit the pipe specification to define a cut-off length and placement of a flange at the cut-off length. We can do the same by adding a new row and defining it with a key name called cutoff. Even union key name can be used for this purpose. Define the size as 50 and browse using standard part option and select a flange of the same size. You also need to switch on Use Maximum Flat Length from Pipe Specification from the Options tab. Select Global as the scope, which on the left-hand side, and define the value as 1500, which means that at every 1500 pipe length, a cutoff gets placed. Enable the option Cut off after reaching maximum length and place part automatically. Save the pipe spec and close the pipe specification editor. Let's move to the Solid Edge application. Delete the piping assembly and recreate it with the same pipe specification which we modified using Generate Pipelines. You can preview the cutoff key name in the list. This time it creates the same pipe assembly, however it will add a flange, counter flange, a gasket and clamp at the cutoff value. Let's see how a piping assembly can be created using data from P&ID. If we want to link a 2D component to a 3D component, then the same can be performed by editing the pipe specification. In this case, we will edit the pipe specification, make sure that the Show P&ID ID column is switched on, and link the 2D component from the P&ID component database against the 3D component mentioned in the row. Click on the P&ID ID against butterfly valve, which opens up the solid edge P&ID application where you can specify the article number of the butterfly valve. Once we link the two, the pipe specification has to be saved and the P&ID application has to be restarted. Let's create a simple pipeline connection between two valves and define a size by selecting a pipe specification, tri-clamp standards. The information that is the pipe diameter and pipe specification is going to be shared with the solid edge piping application, i.e. the P&ID to-do list, and the piping assembly will be built. Save the P&ID project file. Now let's create a 3D pipe assembly for the pipeline we defined in solid edge P&ID. Create a new assembly and save it. Initiate Run Piping feature inside Solid Edge Piping Design ribbon group. Switch on Open To-Do List and click Yes to assign a P&ID project. Browse the P&ID project file, select and click OK to continue. We see the P&ID to-do list. You will see the components and pipelines that we defined in the P&ID schematic file. We will place both the valves in the assembly first. Using context menu, place 3D model to CAD. Notice the corresponding 3D parts get placed, which is defined in the pipe specification against the P&ID component article number. Temporarily place both the valves at some position in the assembly. As you place the valves, the component representation changes to green in the P&ID to-do list, which means that the component is placed and assigned. We can select the pipeline from the P&ID to-do list and see the preview of the connection. It shows the pipeline connection points, which need to be connected in the 3D display. Using this information, we will create a pipeline part in the assembly using the Create Route context menu option. This can be created in a new assembly or in the active assembly. In this case, select Active Assembly and click OK to continue. Now you can create the route with either Auto Route or the Manual Route option. Select the Manual Route from the context menu option and Create Sketch. And as we exit the sketch after finishing, the pipe application will start creating the assembly based on the pipe diameter and pipe specification information from the P&ID to-do list. Now the pipeline representation turns green as we created the piping assembly. Now we will create an isometric drawing for the 3D piping assembly which we just created. As the assembly is pre-selected, click Next to Step 1. In the Step 2, the system validates the piping assembly data. You can see the component type and S-key parameters of the components which we have added using the component wizard earlier. We can see that flange has been defined for the component type and S-key parameters have been defined as FLWN, i.e. a world neck flange. Next, we will select the drawing style in which we want the isometric output to be in, along with other parameters, and click Finish to create the isometric output. Here, the system can create multiple outputs like DXF, DWG and PDF outputs. Open the PDF to view the isometric output with world list information. Open the cut list output in Solid Edge and view the outputs with all the table information.
To summarise, for piping design we need to have a library of parts in place with the knowledge like the coordinate system and S-key parameters embedded into it. We also need to create the piping specification according to standards. Then we can make use of these two to build piping assemblies as well as for generating isometric drawings. Thank you for attending this session.